Right, so this equation is super easy to memorize, and you'll use it all the time, and you'll be best friends with it. So yeah, we can go over this real quick. Let's see, let's just do that last question that he has on there. What does the question say?
It says, how many milliliters of conc, C-O-N-C, which is H2SO4, in parentheses it's 18.1 molarity, are required to prepare 1,000 milliliters of 0.010 molarity sulfuric acid. I think that's molarity. He has an italicized, but
This one? Yeah, this would be molarity.
that's molarity.
So C-O-N-C, this just means concentrated.
Okay.
And so it's mostly this, a little bit of water.
Okay.
So required to make what?
Required to prepare 1,000 milliliters of 0.010 molarity sulfuric acid. At least I think that's molarity.
Yeah, that would be. Perfect. So we're looking for the milliliters of this to give us this. And so the equation M1 V1 equals M2 V2. The M here stands for the molarity, and then the V just stands for volume. And so it's saying that we don't know the volume of one, but we know the concentration. So the concentration of the first, because we're looking at how much of this solution do we need, basically. And so for the M1, we can plug in 18.1 for the M1, and then we're still looking for V1, so we just keep that as V1. And then equals, the volume is going to be 1,000 milliliters. So 1,000. Sometimes it's easier to just, because if you do this in milliliters, this answer will give you milliliters. Does that make sense?
That makes sense.
And so we can just simplify this because molarity is in liters.
So it's just 1 liter then?
Right, it would be 1 liter.
Okay.
But we're also looking for our answers in milliliters. So we could just keep it in milliliters, and then it will give us milliliters as an answer for V1. Does that make sense?
That makes sense.
Okay, so we can just keep the 1,000 in here. But just remember, we are only doing that because the answer we're looking for is in milliliters.
Right.
And then the M2 for the final solution is going to be 0.010. And so basically, we just do our algebra. V1 is equal to 1,000 times 0.01 divided by 18.1. And that gives us the volume of this solution that we need to have.
I got 0.55.
0.55?
Yeah. Well, I guess, let me see. It'd be like 0.552 with significant figures, I guess. Or, no, would it be 2 because of the 0.010?
And this is only got 2 sig figs, right?
Right.
So yeah, we would just do 2.
Okay.
So 0.55 milliliters. And that's because this is basically saying take 100th of this, and 100 times what gives us 1,000? 100 times 10, right? So it'd be 10 divided by 18, and that gives us this. Is that right?
I just followed the equation that you showed, but
Yeah. I don't know, my brain's like on slow mo today, so.
it's alright.
Yeah, if you plugged it in the calculator, I believe you. I'm just trying to do it in my head.
So, this might sound stupid, but so like, if the second part was given instead of milliliters and liters, let's say it said 1 liter, you wouldn't. It doesn't matter with the molarity that's given because it's the same thing. If that makes sense, right? like, you wouldn't have to figure out how many, the molarity of, like, say, sulfuric acid if it was a different amount of liters, or would it matter?
Okay, so you're saying, you're asking about these two things right here?
Mm-hmm.
Like if this value affects this value?
Yes.
Okay, no, it does not.
Okay.
Okay, so they're giving us, so basically what this is saying is that they had like this big giant vat or big giant tub
Mm-hmm.
of, so this is just the label on it, 0.010 molar. And so you can just think of some big 50-gallon drum,
Mm-hmm.
and it's labeled this, saying this is the molarity of this solution. And then they just took out 1,000 milliliters out of this bucket. Does that make sense?
That makes sense.
Okay.
Okay.
Yeah. Good question.
All right.
Cool. And so yeah, that and this equation's super straightforward, and I'll help you out with a lot of stuff when you're trying to come up with solutions.
That's good.
So